Till today, internet is not available, so maybe next lecture may be conducted or not, we don't know. So now let us start with the next point, whatever we have discussed. Yes, what we have discussed. Can anyone tell me? कुठेपर्यंत झालं होतं? काय होमवर्क दिले होते तुम्हाला? Okay, as always, you're white. So let us go with the next one. We have studied the necessary sufficient condition for the Lagrange's Euler-Lagrange's equation to be satisfied is that the function f must be total derivative of some function g where g is a function of x and y. Okay. Now I will give you one homework for you people that from the Euler-Lagrange's equation you have to derive. This will be the homework for you from Euler-Lagrange's equation show that f minus y dash dou f by dou y dash minus dou f by dou x is equals to constant. You have to show that this whole term is equal to constant. So how to prove any term to be constant? Prove its derivative is equals to 0. Okay. This is a homework for you. You have to try it. This type of example I have told you earlier in the first case. Right? We have discussed the two cases. Right? Second one, we have studied that the necessary sufficient condition for the Euler-Lagrange's equation to be satisfied is that the integrand f must be the total derivative of some function g, where g is a function of x and y. Okay. Now let us go for the examples on Euler-Lagrange's equations. Okay, why we say it is equations? Because as we studied, what is our equation? What is Euler-Lagrange's equation? ओके वाय वी से लॅग्रॅन्जेस इक्वेशन्स हे तर झालं असेल ना तुम्हाला फर्स्ट चॅप्टरमध्ये लॅग्रॅन्जेस इक्वेशन्स माहिती आहे का ओके लेट इट बी show that the shortest distance between any two points is a straight line. We will start with an example. Show that the shortest distance between any two point is a straight line. Shortest distance between any two point is a straight line. Okay, we have to show that the shortest distance between any two point is a straight line. ये तो हम imagine कर सकते हैं, right? If I have these 2 points, so I can find out the shortest distance joining these 2 points is a straight line. Right? For that, let us start with the proof. Let us consider P and Q be the two neighboring points. Let P x1, y1 and Q x2, y2 be the 2 points on a curve. Instead of saying curve, instead of saying a straight line, we say it is curve because first we will imagine this to be a curve and then we will find out that the distance between the 2 points can be joined by infinitely many miles, but the shortest among them is a straight line. Okay, now to find out the distance between the 2 points P and Q, which is a straight line. So for that, what we will consider, let xy, x plus dx, y plus dy be the two neighboring points, be the two neighboring points on the curve, if ds, what we say, if ds is a distance between the two neighboring points, then I can calculate this with the help of x plus dx minus x minus, plus y plus dy minus y, it's a square, right? So what is this total distance ds between the two neighboring points? I can say it is simply dx square plus dy square, right? Now we already we have done this in the starting of the first unit, I think. So you have to just divide by dx. So what I get the result 1 plus dy by dx bracket square. So if dx is outside, so what we get the result ds is equal to 1 plus y dash square dx, right? Now we have to find out the total length between the 2 points P and Q. Okay, first we will imagine them to be a curve and then we find the distance between the two neighboring points, that is x plus dx, y plus dy, and the first point is x and y. First, we'll find out the distance between the two neighboring points, and then we'll say that the shortest distance between the 2 points P and Q is a straight line. First, we'll consider this to be a curve. Okay. Now, the total length between the 2 points P and Q is given by total length between the point P and Q is given by integration within the limits p to q ds is equals to integration p to q 1 plus y dash square ds, right? So we get it is equal to integration, I can write x1 to x2 as we are integrating with respect to x. So that's why we are going to find out the limits within x1 to x2, right? Now we have studied our Euler-Lagrange's equation. What is the condition for I to be extremum? That the integrand f must satisfy Euler-Lagrange's equation. For I to be extremum, in this case it is a minimum because we want to find out the minimum distance between the 2 points. For I to be extremum, the integrand f, that is this is f, right? What is your integrand I in our Euler-Lagrange's equation? x1 to x2 f of x y y dash dx. Okay. For I to be extremum, the integrand f must satisfy Euler-Lagrange's equation. What is your Euler-Lagrange's equation? Dou f by dou y minus d by dx of dou f by dou y dash, right? So this is what your equation. Okay, now here what is your integrand f? Under root of 1 plus y dash square dx ला सोडून जे काही असेल त्याला आपण इंटिग्रंट म्हणतो, करेक्ट? Now by using Euler-Lagrange's theorem, for I to be x minimum or shortest distance, the integrand f for I to be minimum, the integrand f must satisfy integrand f, you can write down f equal to under root of 1 plus y dash square must satisfy Euler-Lagrange's equation. Okay, let me write down the Euler-Lagrange's equation. Dou f by dou y minus d by dx of dou f by dou y dash is equal to 0. Now f is known to you, find out the derivative with respect to y. Is there any term of a y? f मध्ये y दिसतो का?
No, ma'am.
So what is the derivative? Yes, you have to tell me the derivative.
0.
What about the next term? What is dou f by dou y dash?
1 upon 2 root 1 plus y dash square into 2y dash.
Okay, so this is 0 minus d by dx as it is. So 2 get cancelled. Can I write simply as y dash upon under root of 1 plus y dash square equal to 0? Right? Now if I want to solve this equation, what we will do instead of finding the derivative with respect to x, it will be somewhat difficult. Right? So because it is one of u upon v rule, no? While finding a derivative, you have to use a u upon v rule. So what we will do, we will integrate the above equation with respect to x. Integrating with respect to x, what we get, it is y dash upon under root of 1 plus y dash square is equal to some constant c, correct? Now if I write this as y dash is equal to c into under root of 1 plus y dash square. Now if I take a square on both sides, it is y dash square is equals to c square 1 plus y dash square. Right, now if I take a y dash square outside, what we get, y dash square if I take outside 1 minus c square. You can write this as c square plus c square y dash square. So taking y dash square common. So here you remain with 1, here you remain with the minus c square, it is equal to what we remain, c square. Have you understood this step? Okay, so what I get, y dash square is equals to c square upon 1 minus c square. So in this way we get the value of a y dash is equals to under root of c square upon 1 minus c square, it is equal to c upon under root of 1 minus c square, correct? So in this way you get the value of a y dash. What is c? We have c is a constant of integration we have written here, no? इस स्टेप में आपने इंटीग्रेट किया और व्हाट इज दिस c is a constant of integration. So c upon under root of 1 minus c square, again it is some constant. I can name it as some k. Is the idea clear for this step? Constant है
Yes,
c
ma'am.
upon under root of 1 minus c square ते पण एक constant येणार आहे, right? So you can write this as now integrating again you can get this as this is nothing but dy by dx is equal to some constant k. So again integrating you get y is equals to kx plus b, which is nothing but the equation of a straight line. बरोबर ना? So whatever we have
Yes,
imagined
ma'am.
that from P to Q, the curve we have imagined for I to be extremum, what is the condition on that curve? It is a here. This because of this condition itself we have found, no? For I to be extremum, the integrand f must satisfy the Euler Lagrange's equation. If you remember, we have found dou I by dou alpha and equal to 0. First derivative equal to 0, then second derivative check करतो आपण ना, whether it is greater than 0, less than 0, then we find the maxima or minima. Now in this case, we are considering the minima. So for I to be extremum, the integrand f satisfy the Euler Lagrange's equation. In solving Euler Lagrange's equation, we get the equation y is equals to kx plus d. Is that okay? Any doubt for this example? Now there is one note. Geodesy is a curve which gives the shortest distance between the 2 points. Okay, this is what simply a definition of geodesy is a curve which gives the shortest distance between the 2 points. Okay. Now next example is show that the geodesy on the surface of a sphere is a arc of a great circle. Okay. Show that Geodesy on the surface of a sphere is the arc of a great circle. Yes, whether you understood what is given, what we want to prove. Second example, show that geodesy. What do you mean by geodesy? Geodesy is a curve which gives the shortest distance between any two points. Okay, आपके it is a curve which will give you the shortest distance between the any two points. Now here we what is our aim to show that in the next one क्योंकि आपको ऐसा लगेगा कि shortest distance between any two point है always a straight line नसतो. Okay, if you have a surface, so at that time you cannot say that the shortest distance between any two points is a straight line. अगर आप plane पे हो, plane पे आपको कोई restriction नहीं है, so at that time you can say it is a straight line. But suppose if you are on any surface, suppose you are in a 3D space, that at that time also shortest distance between any two points is a straight line. If you are on 2D, again the shortest distance between any two points is a straight line, right? You must see the proof of this. I have shown you the proof for the shortest distance between any two points is a straight line on a xy plane, right? यहाँ पे सिर्फ y और x दो ही वेरिएबल कंसिडर किए हैं हमने प्रूफ में, करेक्ट? So you should go with this example. Okay, what will happen in a 3D space? Okay, if you are having any two points in a 3D space, whether the shortest distance between any two points is a straight line, and you must see the proof of this. जे एक्झाम्पल मी घेतीये तेच येणार आहे असं काही गॅरंटी नाहीये. These are simply example. जे एक्झाम्पल आपण आपले टीचर घेतात तेच यावं असं अपेक्षा करू नका. Show that the shortest distance, or we can say show that the geodesy on a surface of a sphere is the arc of a great circle. Now we have studied what is a circle. What do you mean by great circle? Geodesy कळाला सगळ्यांना? It is simply a curve which give you the shortest distance between the any two points. Now here we have to show that the shortest distance between any two points on the surface of the sphere. Okay, imagine करा तुमच्याकडे एक sphere आहे. Okay, just imagine that you have a sphere. Okay, now what is our aim to do? We want to find out that what is the shortest distance between the any two points on the sphere, and what is our aim to show that it is equal to arc of a great circle. Okay, काय करायचं? Imagine करा की तुमच्याकडे फुटबॉल आहे. Okay, so if we have a football, we are going to divide it. Okay, कट करायचं. So what do you get at every point? क्या मिलेगा आपको अगर आप एक फुटबॉल को कट कर रहे हो? सो एट एवरी पॉइंट ये वाला क्या होगा आपका? ये पार्ट, व्हाट इट लुक्स लाइक. इमॅजिन करा फुटबॉल घ्या, फुटबॉल घेऊन त्याला कट करा व्हर्टिकली. सो व्हॉट यू विल गेट? कॅन एनीवन टेल मी? Yes, is it so difficult? You cannot imagine that how to cut the football or any spherical object.
Sphere.
What do you get? Yes, someone told me what we get.
Hemisphere.
Semisphere. Okay. Yes, anyone else want to say? हा बाकीचे विचार करत नाही काही येत नाही किती सोपं आहे. बघतायत ना लेक्चर का चालू करून जातात कुठे काय रिस्पॉन्स नसते कुणाचंही. एक किंवा दोन स्टुडंट बोलतात ते पण कधी कधी. हम्म. Is it so difficult? You have to take a one sphere, you have to cut it. Okay, cut करून पण दाखवलेत. But it is on a 2D plane. You have to imagine. Okay, you have to imagine on a 3D space and you have to tell me what you get. Okay. So if you cut it, so whether you are going to get it is in the form of a circle itself, circle ही मिलेगा ना आपको. ऐसा दिखेगा ना वो आपको कट करने के बाद. So you will get this अलग अलग शेप के मिलेंगे सभी क्योंकि आप कट कर रहे हो उसको राइट. You will get the shape of this type के आप suppose you cut it so you will get like this. थोड़ा बड़ा हो जाएगा फिर then again it will become smaller and here you get like this. बरोबर ना. Okay, I hope you understand and you get it. So, if suppose I want to find out the from the center, suppose here is the center of the circle. So, whatever this one I am getting, this is the largest circle we can get. This here, as I shown you, this will be the largest one. All other circles will be the smaller one. Okay. So here this will be the largest circle, so that's why instead of saying this to be largest, it is told that in our statement that geodesy on the surface of a sphere is a arc of a great circle. Okay, geodesy on the surface of a sphere is a arc of a great circle. Okay. Now here, if you think about the last example, what we have done in the last example, we have found the minima. Okay, last example मध्ये काय केलं होतं आपण 2D plane होता काय restriction नव्हते इथे काय restriction आहे these are all the points on the surface of the sphere. Okay, in the 2D plane it is easy, you can find out the shortest distance. Okay, minima find out kelet, but here we have to find out the maxima. Why? Because we are considering these 2 points on the ग्रेटेस्ट सर्कल. ओके, क्योंकि आप जब आपके स्फीयर को कट करोगे तो वो आपको सर्कल के फॉर्म में मिलेगा सभी राइट. एंड द सर्कल विच इज गोइंग पासिंग थ्रू द सेंटर, ये वाले बाकी के जो सर्कल है उससे जो आपका सर्कल सेंटर में से पास हो रहा है उसको जब आप कट करोगे तो वो ग्रेटेस्ट होगा. सो दैट्स व्हाई वी कैन से दैट इन दिस केस वी आर फाइंडिंग द मैक्सिमम राइट. Now let us consider ds with the infinitesimal distance between the 2 points. Again we will consider two neighboring point x y z, x plus dx, y plus dy, z plus dz. These are two neighboring points and ds with the smallest distance between the 2 points, and it can be find it as dx square dy square plus dz square. Right? So distance between the 2 points. Now we know the relation between the Cartesian coordinate and polar coordinate for the case of a sphere. Okay. Those who remember, I think we have done this in the first chapter. Spherical pendulum. आठवते का spherical pendulum? Okay, these are what the relation between the Cartesian coordinate and polar coordinate. Now what is r? R is a radius which is fixed. Correct, radius of the sphere which is constant. Okay, now we have to find out the value of dx, dy and dz, then add them, then square them and then add. Right, so for that first I should find out the dx, dy and dz. Okay, while finding you have to consider theta to be uh, variable, right? So here we can find out the derivative with respect to x. R as it is a constant which is outside. Derivative of theta and phi, we have to consider them as a generalized coordinate. They are linearly independent, no? So you have to find out a derivative with respect to that only. Okay, so what is the result? First we will find out the derivative with respect to phi. Okay, sine theta as it is, derivative of cos phi is minus sine phi d phi, correct? Plus r as it is again, cos phi will be as it is, derivative of sine theta is a cos theta and d theta, correct? Next, sorry, here it should be dx, no? ये वाला dx है. Let me write down this is dy. Okay, what is the derivative of dy? That is r as it is, sine theta as it is. Derivative of sine phi is a cos phi d phi, plus in the next one we will find out the derivative of a sine theta. First sine phi as it is, derivative of sine theta is a cos theta d theta. Correct? And the last one minus r, derivative of cos theta is sine theta d theta. Correct? Now in this way we have found the value of dx, dy and dz. Now squaring them and adding, we get dx square plus dy square plus dz square. It is equal to, yes, what we will get, dx square. What is the value of a dx square? R square sine square theta sine square phi d phi square. Right? Plus next r square cos square phi cos square theta t theta square. बरोबर. Now as it is a minus, I can say minus 2 times r square and the value of all those terms, sine theta, sine phi, cos theta, cos phi. ऍक्च्युली हे काढायची गरज नव्हती, तुम्ही ऑलरेडी काढले थे एक्स डॉट स्क्वेअर प्लस वाय डॉट स्क्वेअर प्लस झेड डॉट स्क्वेअर, आठवते का? सो इन्स्टेड ऑफ wherever it is dot, you have to write down theta dot जिथे लिहिले तिथे d theta लिहायचे, d phi dot जिथे लिहिले d phi लिहायचे. ओके, आठवते का, केलंय का नाही?
हो मॅम.
Yes, ma'am.
dy square, what is dy square? R square sin square theta cos square phi d phi square, plus next term is r square sin square phi cos square theta d theta square plus 2 times. Okay, as it is a plus b bracket square, a plus b bracket square, so we'll write down the two terms, ये वाला और ये वाला cancel हो जाएगा, right? And the last term I will write down r square sin square theta d theta square. Okay, so I hope you have done this, so that's why I will write down directly by all the cancellation, addition, and then sin square theta plus cos square theta हे one असतं ना. So by doing all this, I hope you got this as r square theta dot square. Theta dot square च्या जागी काय लिहायचं ते d theta square plus sin square theta as it is, right? Now instead of d phi square, you have to sorry, phi dot square, we have to write down d phi square. बरोबर? What was the answer you have found? X dot square plus y dot square plus z dot square is r square theta dot square plus sin square theta into phi dot square. So जिथे डाउट आहे तिथे फक्त d theta आणि d phi लिहायचे. Okay? So in this way we have found the value of ds is equals to under root of dx square plus dy square plus dz square is equal to, just you have to take a under root and we get it is equal to ds is equal to under root of the term which is r square d theta square plus sin square theta d phi square, which is equal to, I can take r outside and b remains with d theta square plus sine square theta and d phi square. This is what d is. Now the total distance between the 2 points P and Q. What is the total distance between the 2 points P and Q? Is given by the integration P to Q. ds is equals to integration P to Q, the value of this whole term, right? R is outside. Now here I can take d theta outside and we can write it as 1 plus sine square theta is outside, and here we can write d phi upon d theta. Divide by d theta, it's square, d theta common घेतला इथे, okay? Instead of taking dx, in the last example we have taken dx outside. R is a constant which is outside the integration. Now as we are finding the integration with respect to theta, so we can write this as integration P to Q, 1 plus here sine square theta, and this is what I can write this as phi dash square d theta, correct? Instead of writing d phi by d theta, we can write this as a phi dash square, okay? Now this is what your integrand now, correct? You can write this as r also. R को अगर आप अंदर मल्टीप्लाई करेंगे तो आपका इंटीग्रेंड क्या हो जाएगा? This is what for I to be extremum, the integrand f must satisfy the Euler-Lagrange's equation. Correct? Now, what is your Euler-Lagrange's equation? F with respect to y minus d by dx of f with respect to y dash is equals to 0. Okay, now just find out the derivative of integrand f with respect to y and with respect to y dash. Is it possible? But here as your integration, यहाँ पे आपका integration का value क्या है? F of x y y dash. These are the terms, right? X y and y dash था. यहाँ पे क्या है? It is in terms of r theta phi. बरोबर? तो क्या करेंगे हम लोग? आपका जो function है वो x y y dash में नहीं है. So we can write now the equation in the form of yes. F with respect to y. Y का क्या रोल है यहाँ पे? Right? We are finding the derivative with respect to x, so we cannot write down. So with respect to y means what? With respect to phi I can write. Okay, y चा रोल इथे काय करणार आहे? phi minus d by dx instead of x. Now integration इथे with respect to x आहे, इथे with respect to theta आहे. Correct? समजतंय का सगळ्यांना? हॅलो, आहेत का?
Yes, ma'am.
Now here x y y dash. So instead of x y y dash we have here the another variable. So यहाँ पे dx की जगह पे क्या आएगा? d theta. What we remains now here? F with respect to y dash की जगह पे क्या आएगा यहाँ पे? phi dash equal to 0. Correct? Now what is your integrand? Now integrand f must satisfy Euler-Lagrange's equation. So our integrand f is r under root of 1 plus sine square theta phi dash square. Okay, just find out all the derivatives. In the next lecture you should find out the derivative and find out the integration up to that, and then we will solve this equation. Okay, phi dash पर्यंत काढून ठेवा, नंतर आपण सॉल्व करूया. ओके, डेरिव्हेटिव्ह काढता येते ना सगळ्यांना? Find out the derivative with respect to phi dash with respect to theta and then finalize it. Solve kara. Okay, and I hope you are knowing your internals are declared. Hello.
Yes, ma'am. Yes.
So what is the date of the internals? Okay, study internals. The date of internal is from 13 onwards. 13 को आपका जो फर्स्ट पेपर है रियल, देन अलजेब्रा,